Okay, so we're back to do a little bit more with the word problems for Module A. So the next one you can see here on your screen from the notes talks about angles of a triangle. Again, we did this one like this in Math 95, so if you did Math 95, you would have seen these, but if you came through a different path, hopefully you've seen it at some point also. The thing to remember here is that any triangle, the three angles add up to 180 degrees. So that's kind of outside information you have to bring in. In this problem, it doesn't say that, but you need to know that. So here, talking about the angles, they're described in terms of each other, and both the second angle is described in terms of the first, the third angle is described in terms of the second. So I need to know the first, something to represent the first angle. I'm going to call it x. The second angle is twice the first, so twice means 2 times that, so 2x. The third angle is 30 degrees more than the second angle, so 30 plus 2x. Now sometimes people are tempted to say, well, I'm going to call the first angle x, the second angle y, and the first angle x, second angle y, third angle z. Similar to sometimes with the consecutive integers, they want to say, well, it's x, y, and z. The trouble with that is then we'd have 3 unknowns. We would need 3 equations to solve that, which we haven't gotten into. So we want to just, when we can, we want to use just one variable, one unknown. Then I know that these 3 are going to add up to 180. Again, from here, it's a simple linear equation to solve. Just remember that we're asked to find all 3 angles. So x is 30, so 30 degrees is the first angle. The second angle is twice that, or 2 times x, 2 times 30 is 60. The third one is 2 times 30, which is 60, plus 30 is 90. Again, you want to double check it. You can check that they add up to 180. Okay, now we get into some other ones here. There's one about a perimeter. And again, that sort of outside information you need to know is what a perimeter is. So a perimeter is all the way around the outside of a shape. For a rectangle, that means you go the width, the length, the width, the length. So 2 of each of those. 2L plus 2W. I set this up 2 different ways. There are 2 unknowns here. This should say dimensions, not dimension, but it means length and width. That's what we're finding. So we could say, let the length equal L, let the width equal W, have 2 different variables there. In that case, we need 2 different equations. We need a system. So I could say, well, the perimeter is 2L plus the 2W, and my length is 2 times the width. It's 2 times as long as it is wide. So whatever the width is, twice that is the length. Now I would put 36 in here for P, because I know the perimeter is 36. I would then have 2 equations. This one is already nicely set up for substitution, so that 2W could go in for the L. So when I rewrite this equation, I've popped that 36 in for the perimeter. 2 times 2W in place of L, plus 2W, distribute, combine, solve. W is 6, that means the length is 12. The length is 2 times as long as it is wide. The other way I could do it is I could choose to just have one variable and have that 2 times as long as it is wide in here when I define my variables. Okay, you can see it's very similar. Either way would work. When I have 2 unknowns, I can sometimes, depending on the problem, do it with one equation or 2. All right, then we have several that are sort of similar. So, or a few here. So example 8 talks about is a situation where we say Stephen has 2 times as many nickels as quarters. Okay, so again, think about that. How many quarters he has? He has twice that many nickels, and they have a combined value of 140 cents. So again, I set it up both ways. I could have nickels and quarters both have their own variable. Nickels is twice as many quarters as I have. Again, nicely set up for substitution. We can pop it in there, find quarters, and then just say, okay, twice that is the number of nickels. Or I can have that twice as many reflected here, have one equation, and solve that. Now I want to show you, when you look at the videos that Lumen has provided for these, often they use a chart. And so I did that in some of the other ones, but I want to kind of show you how that works for this one. And I do like the chart. I didn't put it in there, but I think it helps people kind of figure out how to set up those equations. me find where we are here. Okay, so the chart that we use has sort of a similar pattern usually. So we have, we make the chart with a few columns and rows here. Okay, so I'm just going to sort of generally show you what's in the chart first, and then we'll do it for this example. So usually I'm just going to be very general, okay? The first thing goes here. In this case, we have nickels and quarters, right? So we have the first thing and the second thing, whatever they are. It might be nickels and quarters. It might be two different solutions that we're mixing. You'll see one like that later. It might be two different food items that we're mixing, different things, okay? It might be two different people, whatever the first thing and the second thing that we're talking about are. And then often in this chart, we're going to have, again, this is very general, very not mathematical here, but sort of the number of each thing, the value of each thing, and then the total value. Okay, so this comes from multiplying these two. Sometimes we have sort of a total down here also. Okay, this will make much more sense once we do this example. So let's do it with this example of the nickels and quarters. Okay, so our two things are nickels and quarters. And we can fill out the chart. Let's say that we've decided to say, let nickels, and really I want to say let the number of nickels equal n, and let the number of quarters equal q. Okay. Those are my two let statements. I've defined my variables, and I like to have as much this as specific as possible here. I don't want to say nickels because there's a lot of different things about the nickels. There's the weight of the nickels, there's the value of the nickels, there's the size of the nickels, right? We want to know the number of nickels. So we have the number of each, we have the value of each, and we're going to have the total value here. So nickels, I'm saying that nickels is n, and I'm saying that the number of quarters is q. Well, what's the value of each nickel? Well, it's 5 cents. So there are a couple different ways we could write this. If we think about it, from the problem, we were told that the total was 140 cents, which we know is another way to write $1.40. So it doesn't matter which way you write this in your problem. We're going to have that as part of the equation, but you want to be consistent. So I could say this is 5 and this is 25 because that's how many cents there are. Right, or just, I'm going to write it in red. Another way to write this is 0.05 and 0.25. That's, written more as a part of $1. Okay, so either way is fine as long as you're consistent. So let's say I have now my pile of nickels. Okay, here, these are all nickels. How do I find out the total value of this pile? Well, it's 5 cents for this one, and 5 cents for this one, and 5 cents for this one, right? 5 cents for each nickel, no matter how many nickels I have. So we multiply those to get 5 times n. If I had 3 nickels, it would be 5 times 3, 15 cents. If I had 147 nickels, it would be 5 times 147, that would give me the number of cents. Now again, just to give you the other option, if you're going to writing the other way so it looks like money, like a dollar amount, then that's how we're going to write it out. Okay. This one is going to be 25Q, or again, you could write it as 0.025. Oops, not 0.025. That's a little too small, isn't it? 0.25Q. So you're doing one or the other, either the what's written in black or what's written in red. Okay. So we know now that he has 2 times as many nickels as quarters. So that tells us how these two are related. And we know that whatever the value is, so he has a pile of nickels, and then over here he has a pile of quarters, right? whatever the value of this is plus the value of this has to equal that 140 cents. Or if you're writing it the other way, it would equal $1.40. So that's going to give us our other equation. And that's often what happens, is that this row or this column and this column give you two equations. So our one equation has to be how the nickels and the quarters are related. Sometimes when it says one's twice as many as the other, I kind of have to think about which way it goes. So what this is saying is there are 2 times as many nickels as quarters. Let's say he has 10 quarters. It is 2 times as many nickels, so we'd have 20 nickels. So the number of nickels is 2 times the number of quarters. So one equation is going to be the number of nickels is 2 times the number of quarters. Then from my chart, my other equation is 5n plus 25q equals 140. Or again, you could use what's in red here. It can look the same except for where the decimal points are. So these are my 2 equations. Okay. I had those equations written on there. Some people, are really comfortable with this and can just write your equations from the information, and that's fine. I do find the charts help people, especially if you're not as familiar with this or not as comfortable with it. Okay, so let me go back so you can see. So again, this is a great way to do this. If you look at those Lumen videos, you will see them use the charts a lot. I'm going to skip down past these 2 for just a minute and go to 11 and 12, because 11 and 12 are really a little bit more similar to the one we just did. So here a store owner wants to develop a new snack mix by mixing chocolate and trail mix. How many pounds of chocolate costing $16.60 per pound should be mixed with 13 pounds of trail mix costing $4.50 per pound to create a mixture worth $10.55 a pound? Okay, so a lot of words there, right? Here's the general idea. You're going to make a new snack mix. You're going to mix chocolate and trail mix. Okay, the chocolate is expensive. It costs $16.60 per pound. The trail mix is cheap. It's only $4.50 a pound. Okay, you're going to mix them to make a snack mix. That's some chocolate, some peanuts, some raisins, whatever's in there, right? So if you had mostly chocolate and just a little bit of trail mix in there, it would cost almost that same amount. It would cost $15, $16 a pound. If you took a whole bunch of trail mix and just put in a little tiny bit of chocolate, it would cost much closer to that $5 a pound, $4.50, $5, $6, somewhere around there. Well, we want to create a mix that's sort of in the middle somewhere, right? $10.55 a pound. So we have to know exactly how much of that chocolate we're mixing to hit that price point of $10.55 a pound. For this one, we actually only have one unknown, okay? I put 2 unknowns in here, but we really never use this T because we know how much trail mix we're using. Often with a problem like this, we don't necessarily know how much of one we're using. And we would have C, T, and then maybe we want to make 20 pounds total. So this would be here, C plus T equals 20. Okay, but in this case, we know how much trail mix there is. So I did use a chart here. Again, you can see here are my things. There are 3 this time because it's the 2 parts and the mixture. Number of pounds, price per pound, and then the total price. So same idea. C pounds of chocolate at $16.60 a pound. This is the total value of the chocolate, right? $16.60 for this pound, for this pound, for this pound, however many there are. Here I know the trail mix is 13 pounds. I know the price per pound, so I know the trail mix is going to have a value of $58.50. My new mixture is going to be 13 pounds plus however much I add of the chocolate. That new mixture, we want to have it be $10.55 a pound. So it's going to be $10.55 times however many pounds there are. This is going to be my equation. Because I only need one equation this time, it's going to be one unknown. So however much the value of the chocolate is, plus the value of the trail mix, is going to equal the total value of the new mixture. So then I solve for that number of pounds of chocolate. Okay, same idea here for this alcohol solution. Just real quickly, think of it as a really, it's like an alcohol solution you'd see in a science lab. Think of one that's really strong, one that's weaker. I'm mixing them to make a middle strength solution. Same idea here. Okay, I'm almost out of time for this video. I'm going to stop it, and I will come back with a little bit of stuff about the other word problems, but then move on.